Well, good morning, everybody. Today we are starting a brand new topic called properties of exponents, or in this case, topics of exponential functions. So now that we have gone over most of the stuff that's related to straight lines or linear functions, anything that's to the first power, now we're going to start discovering things with different powers. So hence the exponential function. Okay, but before that, I would like to do some discovery with you, so that way we are prepared to know the reasons of the formulas that we're going to learn today in the lesson 5-1. Okay, so this is not actually a review, but it's more of a discovery. Let's take a look at this discovery right here. Now, there are 6 separate problems here, and ahead of time we probably know how to do some of these problems. So let's take a look at this problem right here that says 2 to the third power. Well, the meaning of 2 to the third power is to have the number 2 multiplied by itself 3 times, right? That's what the third power means. So 2 times 2 is 4, 4 times 2 is 8, so I know the answer ahead of time is 8, right? So 2 to the third power is 8 because of 2 times 2 times 2. Well, what about 2 squared? Well, 2 squared means you have the 2 multiplied by itself 2 times. So 2 times 2 is 4 right there, okay? Then 2 to the first power just means write the 2 only once, and you're not really multiplying by anything else besides 1, right? So 2 itself is just 2 there, okay? Then you're like, well, then what is 2 to the 0? Like, am I not going to write any 2's or something? So there's not really any work here, but let's talk about these patterns of numbers. So from 8 to 4, how do I go from 8 to 4 from 4 to 2? Should I add? Should I multiply? Should I subtract? Or should I divide? Well, I see that 8 divided by something is 4, and 4 divided by something is 2. And looks like the pattern is I just divided by 2. So 8 divided by 2 is 4, 4 divided by 2 is 2, and if I were to follow that pattern, then the next answer is going to have this number 2 divided by 2. So 2 divided by 2 is 1. So somehow 2 to the 0 power is 1. And I want you to remember that because we're going to come back to it later in the lesson. So 2 to the 0 power is 1. Well, then what about 2 to the negative first power, right? Or 2 to the power of negative 1. Well, I don't even know what it is. I don't think it's going to be, there's any work involved, but let's actually continue to follow the pattern. So since I keep dividing by 2, I'm going to have 1 divided by 2, and I'm going to write it as a fraction. Since 2 cannot go into 1 evenly, we're going to write as a fraction. So 1 divided by 2, it's going to be half, or 1/2. So that means 2 to the negative first power, it's somehow 1/2, and we'll explain why later, or actually I'll create a formula to remind you that anything to the negative first power, or negative second power, or negative exponents, it's going to give you still a positive answer, but in a fraction form. Well, then let's continue the pattern. So 2 to the negative second power, if I were to continue the pattern by dividing by 2, so when you have half a pizza, and you divide it by, cut that more in half, then you have half of a half, which is a quarter, so 1/4. So from here we discover 2 things. One is if you raise to 0 power, the answer is 1. And you raise to the negative exponents, your answer becomes a fraction. Okay, so I do want you to remember that. Well, the second discovery would be this right here. If you have 3 squared times 3 to the 4th, let's actually do this without a calculator. So we're not too concerned what 3 squared equals to, and we're not concerned what 3 to the 4th power equals to, but let's write it out. Well, 3 squared means 3 multiplied by itself 2 times. That's what 3 squared, right? Well, then what about 3 to the 4th? It's going to be 3 multiplied by itself 4 times like this. And then in the middle, I put the multiplication sign. So I'm going to bring down this multiplication sign like this. Well, let's have you count. How many 3's did I put here that multiply by each other? Let's count. 1, 2, 3, 4, 5, 6. So I could rewrite it as 3 to the 6th power. And that's my answer. Now, I'm not really too concerned about what's 3 to the 6th power because it's going to be a large number. I'm just concerned that, well, is there any shortcuts that I could find with the exponents 2, exponents 4, and without any of these work, can I find some shortcuts, related to 2, 4, and 6? Well, you're right. Well, if you were to add these two exponents, 2 plus 4, you get 6. And I'm going to keep the base of the exponents expressions the same. So if I have 3 and 3, my base is kept the same, which is 3. But if I have an exponent of 2 and exponents of 4, I could add them and becomes a 6. So if I were to have a separate problem, let's say 3 to the 11 times 3 to the 16, I'm not going to write out all the 3's because it's going to be a lot. Well, the shortcut is you're going to keep the 3 and then you're going to add these exponents. So 11 plus 16, which is going to get you 27. And then that's your shortcut to multiplying exponents. So we're going to discover 3 shortcuts today. The zero exponents, the negative exponents, and also the product rule. That's what we call. Okay, so let's go to the next lesson. Well, this lesson is called 5-1 Review on Properties of Exponents Day 1. And the reason it says review is because this standard has been taught in middle school 8th grade. So at the high school level, we're just going to do these problems quickly, going over different rules that you probably have seen before in the past. So let's talk about the zero exponents property. So as discussed from the review part of this video, that if you've raised the number to 0 power, your answer is always 1. So let's do these example ones quickly. So that means 5 to the 0 without any work, it's just going to be 1. Well, 23 to 0 power without any work, your answer is going to be 1. Well, if you don't have a number, you have an expression of variable x, right? It doesn't matter if it's x, if it's y, if it's a, b, or c, z, or c, then any letter to 0 power is 1, assuming that the letter is positive. And same thing, even if you have a negative number, the whole thing raised to 0 power without any work, your answer is 1. Now, be careful though, e is different. Now, you notice that the difference between D and E is that in part D, the whole negative 7 is being raised to 0 power. That's why you have the parentheses. But for part E, this negative is not part of the exponents. So I kind of have to show work on this. So this is how you would show work on your homework as well. So you first, if you see that there's no parentheses, with the base, which is negative 7, you're going to separate them into negative 1 times 7 to 0 power, right? Because the negative is not being raised to 0 power. Only the 7 is being raised to 0 power. So from here, you're going to find, well, so negative 1 just negative 1, and then just 7 to 0 power is 1. So negative times a positive is negative number. So you have negative 1 for your final answer. So just be careful. If you have a negative base, if it has a parentheses, it's going to be 1. If it's without parentheses, you kind of have to show work to get to negative 1. Okay? Well, let's go to the next property that we have discovered from the review part of this video. The next one is called negative exponents property. So here's a shortcut. If you have a number raised to negative exponents, all you have to do is to convert it to a fraction with 1 over the same base, but change the negative exponents to positive exponents. So let's take a look, and we're going to learn how to show work on this. So first of all, if you have 3 to the negative second power in part A, example 2a, if you have 3 to the negative second power, here's a shortcut that I would ask the 8th grader to show work, where you have 3. So first of all, write it as a fraction. Then I want you to do a method called circle arrow. That means every time you see a negative exponent, I want you to circle the whole thing and then draw an arrow to the other side of the fraction. And once you do this, that means the 3 to the negative second power, once you move it down to the denominator of the fraction, it becomes positive exponent. Now there's nothing left on the top, so you still have to write something, which is going to be 1. So it's going to be 1 over 3 squared, and then you have to simplify furthermore. What's 3 squared? Well, 3 squared is just 3 times 3. So 3 times 3 is 9. So your answer is going to be 1 over 9 for part A. Well, let's take a look at part B. What happens if you have a negative exponent on a denominator? What do you do? Because this rule only tells me what happens when the negative exponent is on a numerator. So to do that, I'm going to first copy the problem again. So 1 over 5 to the negative second. And I want you to circle the entire exponent with the base, right? Since it's negative, you move it to the other side of the fraction, which is the numerator part. Then once you swapped it, the 5 to the negative second becomes 5 squared. And then at the bottom, you have nothing left. You still have to write something, which is 1. Now, 5 squared over 1, it's just same as 5 squared because you could just not write the fraction when there is a 1 on the denominator. And then 5 squared is just same as 5 times 5, which is 25. So 1 over 5 to the negative square equals 25. Let's try one more, part C, right? So part C, I'm going to copy the problem, 2 over 4 to the negative third power. Again, if you see negative exponents, you're going to do circle arrow, okay? Circle arrow. So now the negative exponents becomes positive once you move it to the top of the fraction. So it becomes 2 times 4 to the third power, like this. And then at the bottom, you have nothing left, which is just put it over 1, right? Or you don't have to write it, which is just same as 2 times 4 to the third power. Now, order of operation tells you to simplify the exponents first before multiplication. So you have to find out what's 4 times 4 times 4. So for this one, I have to find out what's 4 times 4 times 4. So if you use a calculator, you get 64. So that just same as 2 times 64, which becomes 128. So that means 2 over 4 to the negative third power. With all these work, it becomes 128. Well, let's take a look at more examples. Example 2, using negative exponents and zero exponents. You notice that in this part of the example 2, most of the stuff becomes variables, such as x, y, z, a, b, c, f, different letters. So your answer is not going to be a number, but it's going to be an algebraic expression that's containing these letters. But the process of doing it is going to be the same thing. Let's take a look at part D. So part D, it says 2x to the negative third power. Well, to simplify that without writing negative exponents, your goal is to make all the exponents positive. So to do that, you're going to recopy the problem. Let's make it a fraction, which is over 1. And then you do the circle arrow. So you're going to circle the letter with the negative exponents, not the 2, just the x to the negative third. You're going to circle, put it to the other side of the fraction, which is the bottom. So that just becomes 2, and then 1 times, and then x to the third. You see the negative third power becomes positive third power. And then from there, you're going to simplify the denominator. So 1 times x cubed is just x cubed. So you have 2 over x cubed, and then that's it. And then that's your final answer. Okay, well, what about part E? Same thing. So first you make it as a fraction. So x squared, y to the negative third, z to the negative 4. Put it over 1. And then you're going to do circle arrow. This time you're going to do 2 circles. One for the y to the negative third, circle arrow. And then the other one is for z to the negative 4th, circle arrow. Right? So I'm going to leave the x squared on the top of the fraction. And then you're going to move the y to the negative third to the bottom, which becomes a positive third. And you're going to move the z to the negative 4th to the bottom, which becomes positive, so z to the 4th. And then now that you see that all the exponents are positive, you finish your problem, and then this is your final answer, right? You see, it's just like a little game of, switching all the negatives to the other side of the fraction to make it positive, okay? Now, what about part F? So let's take a look, okay? So we're going to rewrite the problem. So 4a to the 0, b to the negative 4th, c squared, over 12f to the 5th. How many circle arrows do I need? Well, this time it's just 1 because I only see b to the negative 4th having a negative exponent. So circle arrow. Well, the f to the 5th stays the same. The c squared stays the same. Now the a to the 0 power, that just becomes 1. Okay, so you have just 1 right there. So 4 times 1. Okay, so that means you have 4 times 1, which is just 4 c squared over 12. And I'm going to write alphabetical order. So b to the 4th, f to the 5th. Now, you're not done yet. You have to check, are these two numbers simplifiable? Are they, can it be reduced? So 4 over 12, you could simplify by dividing top and bottom by 4. So 4 over 12 becomes 1/3. So you have 1c squared over 3 b to the 4th, f to the 5th. Or you could write it without the 1. So it just becomes c squared over 3 b to the 4th, f to the 5th. And that's your final answer. Okay. Well, one last example of example 2, part G. So let's recopy the problem for this one. So it becomes 5 squared x to the negative third over y to the 4th. Well, how many circle arrows do I need for this one? Just one of them, because I only see x to the negative third having negative exponents. So circle arrow, and that becomes 5 squared over x to the third, y to the 4th, like this. Am I done yet? Not quite, because I could simplify what's 5 squared. Do you know what's 5 squared? Well, yes, it's just 5 times 5, which is 25. So the same is 25 over x to the third, y to the fourth. And then that's your final answer. Okay? In example 3, we are discovering another rule called product rules. So from the review, if you have the same base with two exponents and the bases multiplied by each other, all you have to do is keep the base and add the exponents. Okay? So let's take a look at part A. Part A says x to the fifth times y to the fourth multiplied by x to the second power times y to the sixth. So you're going to match letter by letter. So I see there's an x's, right? So all you have to do is add the x, and you add the 5 and 2, so 5 plus 2. And then the y's, you write it as a y, and then you do 4 plus 6. So 4 plus 6. So that just becomes x to the 5 plus 2 is 7. And then y is 4 plus 6, you get 10. And then that's your final answer. Isn't this easy? Then for 3b, I see that you multiply 2x with 5x to the fourth power. Now, before you do this problem, make sure that every single letter or variable has an exponent. I see that this x doesn't have an exponent, but there's an invisible exponent of 1. So make sure that you do that. Now, these 2 and 5s are just regular 2 and regular 5 multiplied together. So 2 times 5, I get 10. And then x to the first times x to the fourth, it just same as x to the 1 plus 4, which is 10x to the fifth. And then that's your final answer. Okay? Well, what about part C? Now, this is 5 to the negative 4 times 5 to the negative 6. You see that the bases are the same, which is the 5. So all you have to do is have negative 4 plus negative 6. So negative 4 plus negative 6, if you use a calculator, you get 5 to the negative 10 power. But hold on, do not box this as your final answer. This is a negative exponent. Your answer should not have a negative exponent. You're going to make it positive. So guess what? You're going to make it a fraction. You're going to do circle, arrow, just like on the top. So circle, arrow. So that just becomes 1 over 5 to the 10th power. Now 5 to the 10th power is a very large number. That's like 5 times 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 5 times. That's like 10 times, right? So you're not going to find out what it is. Just leave your answer as 1 over 5 to the 10th power. Okay? Well, part D is going to be the same thing. I see that, well, you have 3 bases multiplied by each other with different exponents. So since all of the bases are 4, you're going to keep the 4 the same. And then you're going to add negative 2, negative 3, and 5. So negative 2 plus negative 3 plus 5. Now, if you were to add negative 2, negative 3, and positive 5, you get 0. So you have 4 to 0 power. Hey, what's a number to 0 power equals to? That's from the first rule that we learned. So a number to 0 power is going to be 1. Just a number 1. And then that's it. Well, here we have 3 more examples. Example E, F, and G. In part E, let's take a look, okay? So for part E, I see there is a negative 2c to the negative 5th multiplied by negative 5c to the negative 3rd. So let's take care of the large number first, right? So you have negative 2 times negative 5, so negative times a negative is positive 10. Then the c, you keep it the same, and you add the exponents negative 5 and negative 3. So it's 10c to the negative 5 plus negative 3. So which becomes 10c to the negative 8th power. But hold on, you don't leave that as your final answer because you have a negative exponent. So you make it as a fraction, and then you do circle, arrow, like this. So that just becomes 10 over c to the 8th power, and that's your final answer. In part F, you have x squared times x to the negative 5th, all divided by y squared times y to the negative 4th. Well, you're going to do the same thing. So first, add the exponent. So you have x to the 2 plus negative 5 over y to the 2 plus negative 4. Well, let's use a calculator to find out what's 2 plus negative 5 and 2 plus negative 4. And you get x to the negative 3rd over y to the negative 2nd. Well, you cannot leave that as your final answer because the exponents are negative. So what you do is you're going to do circle, arrow. There's 2 circles, 2 arrows. So the x to the negative 3rd, move it down. Y to the negative 2nd, move it up. So you're just pretty much swapping places. So that becomes y squared. The negative square becomes positive square over x cubed. The negative cube becomes positive cube. And then that's your final answer. The last example is 1 over x squared times x to the negative 3rd. Same thing. So I'm going to keep the 1 there, the same. And then you keep the x and then you add the exponents. So 2 plus negative 3. Well, 2 plus negative 3 is just negative 1. So it's 1 over x to the negative 1st power. Again, you cannot leave negative exponents for your final answer. So you're going to use circle, arrow, move it back to the top. So that just becomes x to the first power over 1. Now, of course, you can simplify this because x to the first power is just x, so x over 1. And of course, you don't have to write the divided by 1, just leave it without a fraction, so that just becomes x itself. And then that's it. Well, in this lesson, all you have to do is learn these 3 lessons. In this lesson, all you have to do is just review these 3 rules that you may have learned back in middle school. And your homework will be on the worksheets that will practice on these 3 rules. Thank you so much.